So if we talk about the same type of graph that we had yesterday, right? A football player is kicking a ball and giving it an initial upward velocity of 48 feet per second. So we have our person. They're kicking a football. And what does that football then do? Go up. And then
drops down.
Comes down. Okay, that's a terrible parabola, but pretend I drew a little bit better. Okay, the starting height of the football is 4 feet. We represent this width, right? And then it gives us the equation. If no one catches the ball, when will it hit the ground? So what did we say looking at this picture was the location where it hits the ground?
Where it hits the x-axis.
Where it hits the x-axis, the x-intercept. And how did we say that we would calculate an x-intercept? I mean, that's our label, but what math do we do here? Quadratic formula. So it actually could be quadratic formula. It could be completing the square. It could be factoring. It could be a square root, right? Any of those solving options we've talked about. Okay, so in step 1 up here, if we want to find when it hits the ground, we are going to use the quadratic formula. Okay, so let's do that for step 1. So let's see, we'll say negative 48 plus or minus 48 squared minus 4 times negative 16 times 4 all over 2 times negative 16. Right, remember when I said you'd be like dreaming quadratic formula? We do it a ton. Bailey, write this down.
I got a question.
Yep.
Why does every problem have negative 6?
This is gravitational pull. Right? So we have multiple things that are happening with this football. Right? We said that the 48 is its initial upward velocity, right? That's sort of the force that's making it go up. But it doesn't keep going up for forever. Why? Because gravity pulls it back down. And that's that negative 16. Okay? And we'll actually look at that here in a little bit. It comes up again. Who's checking my math? None of you are checking my math. 2560? You're all just trusting me today? I don't know. Doesn't sound like a good idea. I don't trust myself. What do we do after we're here?
Square root, dude.
Right? We take the square root of that number. It's not a perfect square. So if it's not a perfect square, what do we do? Are we going to prime factor and simplify, or are we going to round?
Round.
Why are we going to round?
Seconds, and we can round in seconds.
Right? Because we don't talk about seconds with a square root in the answer. So that gives us negative 48 plus or minus 50. This one, oh, that's not a good 50. This one rounds to 50.60. Okay, then we're going to calculate both of those options. So do we just say both of these are our answers?
No.
No, why not?
You can't have one.
Right? We can't have negative time. And so we'll get 3.08 seconds. Most of the time in a situation like this, right, it would tell you to round to the nearest second. I'm not an Olympic runner here, so a 0.08 seconds doesn't really mean anything to me. Right? I mean, that's just is what it is. What does that 3.08 seconds tell us?
When it's going to hit the ground.
When the ball is going to hit the ground, right? So this is at 3 graph?
Like on the other side.
On the other side, correct.
Before he gets.
Right? It's like, it doesn't make sense, but that's where it is in just the graph in general. Okay? So now let's look at part B. This is new today. Part B says, when will the ball reach its maximum height?
The middle.
Okay, so the middle. We agree with that statement. That's usually a pretty quick one, right? Do we all agree it's reaching its maximum height up here?
Yes.
What is the middle of a parabola called?
The vertex.
The vertex. Excellent. So this is our vertex. How do we find the vertex of a parabola?
H.
Okay, so we can use h comma k if we're in the form y equals x, well, a times x minus h squared plus k. Are we in that form? Nope, so that's not going to work.
Where it's gonna be over to.
Negative b over 2a. So it's negative b over 2a, comma, how do we find the y value? I mean, you just did this on your quiz, and we did a great job of it. We plug it back in, right? Whatever value we get here, we plug in. Okay, so this does not say what's the ordered pair of the vertex. This one says, when will the ball reach its maximum height? Is the x value time, or is the y value time? The x, because this is our time, and this is our height, because of our dependent and independent variables. Right? Okay, so if we want to find the x value, negative b over 2a is going to be our when it reaches its max height. So if I want to find out when the ball will reach its max height, I will do negative b over 2a. Yes, Yusuf?
Why can't you divide 3.08 by 2?
Be careful, because this point, oh, that's why I actually was talking about it. We want halfway in between these 2 points, and this point isn't at 0.
Oh.
So we need to like find a distance in between them and then split it in half, but yes, that is something, and we're going to talk about that in just a minute. You like read my next thought. Okay, so we're going to do negative 48 over 2 times negative 32. Oh, 2a, negative 16. I just already did the math in my head.
Yeah.
This is when it's Friday and I struggle sometimes. You guys know that. Okay, and we get 1.5. What label goes on this? Seconds. Because it's when will it reach its maximum height? Okay, so then Yusuf brought up a really good point, kind of jumped ahead in the thought process, which is perfectly fine, but I can't quite ask the same question. Does it make sense that this is at 1.5 if it's in the middle of 3.08 in here?
Yeah.
Yeah, now, it's never going to quite be perfect because remember we rounded with that square root. So we're not exactly perfect, but I mean, right? We're about halfway in between 3 seconds.
It was 1.54.
Right. So we're in that right ballpark, right? We're not going to be exact. This is exact. Doing negative b over 2a is exact. Finding the distance between these two and dividing them by 2 is not exact because we had to approximate with the square root. However, if you're taking a state standardized test, okay, and you're like, shoot, I forget what to do, and you just find that distance and divide it by 2, that's a great way to go, right? Because we know this is symmetric, we know that we're halfway in between. Okay? So now let's look at question C. How high does the ball go? Okay, so what is that question asking us? What's the highest height at its vertex? right? Its vertex is the highest point, so that's asking us to find this value. So how did we say we would find this value? We would plug it back in. So we need to take the value that we got for our when and plug it back into the original equation. So let's see, negative 16. I'm going to squish it in down here so we can see it all at once. So negative 16 times 1.5 squared plus 48 times 1.5 plus 4.
Is this for B or C?
C.
C. Right? This is the how high does it go? It's the y value because our y value represents height. Our x value represents time. What label goes on that 40? Feet, because now we're talking about how high does it go? Does that make sense? Any questions on that one? Okay, so let's scroll down and let's look at number 2. Okay, so the equations used to represent a child throwing a ball is this, right? We could fill in different values. That's our equation. Where h represents the height of the ball, v is the initial upward velocity, t is time, and c represents the starting height. So this is very much like the problem we saw yesterday where we had to fill in the values we didn't know. Okay, so a child tosses a ball upward with a starting velocity of 15 feet per second from a height of 3 feet. So we first need to write an equation that will model this situation. So if we use our equation up here, what values do we know we can fill in here? I mean, negative 16t squared stays.
The vertical.
Our velocity, which is what?
15.
And what does that go in for? What letter?
B.
B, so plus 15t. What else do we know?
And then plus height.
Plus c, and what does my c going to get replaced with? 3. Do we know what h is yet?
No.
No. Right, so that's just my equation right now. Okay, I'm then asked to find when will the ball reach its maximum height? How do we decide when the ball will reach its maximum height?
What is the vertex?
Okay, so it's in the middle, which is our vertex. How do we find a vertex? Negative b over 2a, comma, plug it back in. If we want when, is the when the x value or is the when the y value?
X.
The x value. So we want negative b over 2a. Okay, so let's do that. Negative 15 over 2 times negative 16. .47. Right, rounding. What label does this get?
Feet. No, seconds.
Seconds, because this is when some of us need to wake up a little bit here. Make sure we're getting this down. We've got lots of sleepy people.
I just have a maker headache.
I know it's Friday, and I know all these things. We just don't want to do anything that ruins our grade at the very end. We're so close, guys, I know. I love my job and all those things, but I go home every day and my husband's like, what's wrong? I'm like, my students are annoying. I'm ready to be done. Truth. Sorry. We're getting to be. I'm dragging you to the finish line, guys.
Carrying the team, Con. You got the team on their legs. Come on.
Yeah, I'm not a very good coach relation person because I'm like, oh, I think everybody should win. I guess, yeah, I'm carrying everybody. I'm carrying the other team too.
What other team?
Because I don't want anybody to lose.
What other team?
I'm just saying in general. I don't like anybody to lose.
She's the coach at the finish line running. Go! Go!
Yes!
Go!
That would be
You
me.
gotta be faster, go!
Maybe now as you're all coming to class, I should run down the hall beside you. Let's go, let's
You're
go.
walking.
No.
Let's go. It's time to get these equations down.
Not airball.
Yeah, no airballs in this class.
Yay! C!
Well, then Drew would be kicked out.
C! How high? How high will the ball go? This joke is never gonna
Plug it
end. It's
back
not
into
even
the
funny anymore.
equation.
huh?
hilarious.
You don't understand it.
No!
No, that's an apple.
We
Up
plug it
here.
back into the equation.
We plug it back in because how high, its highest point, is the vertex, but it's the y value of the vertex. Right? So we're going to take the number that we just got, which was 0.47, and we're going to plug it back into the original equation. So let's see, negative 16 times 0.47 squared. Is this a 15? I forget now.
Yeah.
Plus 15 times 0.47
6.5.
plus
30.
3.
That's 6.57. 6.5.
Wait, where do you get the 15?
Isn't that the problem? I don't know.
Yeah, it's the problem.
Yeah,
No, I'm just-
negative.
I was
or
positive
positive 15.
so.
Oh, okay.
It's
So, yeah.
3.
6.52.
Yeah.
I mean, does that make sense for a child tossing a ball that its maximum height is 6 feet? Yeah.
I was like, no, well, I was tossing the 10.
I mean, it doesn't make sense for like someone